Dividing rational functions is not much different than multiplying them. There's one extra step in there, and it's all based around the fact of multiplying and reciprocals. So say we had 1/2 divided by 3/4. Well, that's the same exact thing as doing 1/2 times the reciprocal, which would be 4/3. Notice that we only flip this last fraction. The first one stays the same. So then you do exactly what we had done before, and you multiply across. You have 4/6, and that can simplify into 2/3. So let's apply the same concept with rational functions. Okay, so here's our first example. What we're going to do is we are going to do this thing that I like to say keep, change, flip. So these are the three things we're going to do. We're going to keep the first polynomial, exactly the way it was. We are going to change the sign to multiplication, and then we are going to flip our second rational function. So keep, change, flip only works for division because that's when we have to do keep, change, flip. You keep the first function, change the sign, flip the second function. And now this turns into just a multiplication problem where our first step is going to be to factor. This is what my problem became after I factored. Double check your work, make sure that you get the same thing. And then now we just simplify. So there's an x plus 3 in the denominator, there's 1 in the numerator, then there's an x plus 5 divided by an x plus 5, and that's it. That's everything that can simplify. So we have x minus 5 times x minus 6 over x minus 1. Again, I'm fine with leaving it in factored form, but you have to include x cannot equal what value of x is going to make the denominator 0. So this is the only one we care about. X can't equal positive 1. So there we go. This is our final answer. Let's look at one more division problem. Okay, here's our second problem. So I see a division sign. The first thing I'm going to do is keep, change, flip. And my new problem is now going to become 9r to the third minus 54r to the second. We're keeping this one exactly the way it was. I'm changing my sign to multiplication, and I'm flipping my numerator and my denominator. Okay, now our next step is to factor. Go ahead, try to factor this problem and see if you get what I will. Okay, this is what I got when I factored. There was a GCF, actually all 4 factored problems for both numerators and both denominators were GCF problems. So you could take out 9 and then R and or a combination of both. So now I'm going to go through and I'm going to simplify. Well, the first thing I see is that I can simplify down like this on both sides. And then you can even say, okay, well, here's an R squared and so is there 1, so that goes away. I have an R there and an R there. And then, let's see, my R minus 6 goes away, and so does my R minus 6 on the denominator. Alright, so my final answer is R plus 1 divided by R plus 5. And don't forget, R can't equal negative 5.